In this video, we are going to continue our notes in section 2.5, and we're looking at example 6 on our notes. So for number 6, we want to find the equation of the tangent line to this curve g of t equals 10 minus t squared when t equals 2. So just to recall, if we have our function here, our curve looks something like this. We want to find that equation of the tangent line at a particular point. So what things do we need in order to write the equation of a line? Well, we need two things. We need the slope of the line, which we'll often use as m, and we need a point on the line. We could call it AB. So to find m, the slope, well, we just need to find the derivative of our function at that point. So for us, we look at the derivative of g at the point 2. That will be our slope. And then to find a point on our line, we'll say point on line. Well, we know that point of interest when t is 2 is a point on our line. So when the input is 2, well, what's the output going to be? Just g of 2. So we could figure that out right away. Well, what we do is just look at our function, consult our function, and say, hey, function, what are you when the input is 2? So that would be g of 2 is equal to 10 minus 2 squared, which is 10 minus 4, which is 6. So what do we need? We need that point, which is just 2 comma 6. That's our point on tangent line. And we need the slope, which is g prime of 2. So in order to find that slope, we need to find the derivative of our function g of t. So let's do that. At this point, I encourage you to pause the video if you haven't done so already to see if you can compute what the derivative of g of t is. And when you're ready, let's look at it together. So g prime of t, well, g of t is just a difference here. So we're going to compute the derivative of each term. The first term is just 10. What we saw in our previous video is that the derivative of just a single constant is 0. So we just get 0 for that first term. Then we're going to subtract the derivative of t squared. Well, t squared, that's just a power with our variable in the denominator, or a variable in the base. So we just use that power rule. So the 2 comes down. Then we have t to the 2 minus 1. So let's clean this up a bit. Well, 0, we can remove the 0 and just write negative 2 t to the 1, or t if you'd like. So the derivative as a function is just g prime of t equals negative 2t. So then to compute the slope of our tangent line, we just plug in when t equals 2 into our derivative. So g prime of 2 is equal to negative 2 times 2, which is negative 4. So now we know what the slope of our tangent line is, and that is negative 4. So now let's just put this together into an equation of a line. So our line will look something like, well, we're using t's for our input here. I'll still use y's for our output though. But our equation will look something like y equals mt plus b, where m is that slope and b is the y-intercept. But we just have a point, which is fine. We can find b from that point. So let's plug in one thing at a time. We know the slope is negative 4. So we actually have y equals negative 4t plus b. And then we also know a point on our curve. We know 2, 6 is a point. So I'm going to plug in 2 for t, which is my input, or the coordinate in my first term. And then 6 I'll plug in for y. I'll plug in 6 equals negative 4 times 2 plus b. And we can just continue. 4 times 2 is negative 8. So now adding 8 to both sides gives me 8 plus 6 is just 14 equals b. So now let's put this all together. I know my slope is 4. I know my b is 14. So the equation of my tangent line becomes y equals -4t plus 14.